Video here. So if you look at this, let me show you a common mistake. Remember, there's not supposed to be a little chattering going on. If you see x plus 4 squared, it is the most forbidden of all forbidden math rules to go like this. Mathematically, I can just square, which means this is x squared plus 16. That is mathematically not sound. We know that something squared, means something multiplied to itself. True? So we have to write this x plus 4 squared out as x plus 4 times x plus 4, which means if we distribute this is x squared plus 4x plus 4x plus 16, which means the final answer for that would have been x squared plus 8x plus 16. Notice they're not the same answer. Now, what you're confusing, I know exactly what you're confusing it with. You're confusing put it to this, and this with this. Look, this is not the same problem. Do we need to take the 2 and distribute it to all the pieces? Yes, so what's the difference? This one has addition. Yeah, correct. You are allowed mathematically, are you listening? You're allowed mathematically to square across multiplication and division. You are never allowed to square across addition and subtraction. All right, so we're going to see this. Look at this problem with me. If you need to write it down in your notes, do. When you see 1 plus 2i, don't be the sad soul that says I'm going to square it. Instead, you say to yourself, mathematically, I need to write this as 1 plus 2i times 1 plus 2i, and then I have to distribute. So then I do 1 times 1 is 1. 1 times 2i is 2i. 2i times 1 is 2i again. 2i times 2i is 4i squared, which makes this a what number? A negative 4. I'm really impressed that you're able to just jump to that at this point. Do you guys see how they're jumping to that? Because they're doing in their head, that's positive 4 times negative 1, which is negative 4. Now combine real numbers to real numbers. 1 minus 4 is negative 3. Combine imaginary to imaginary. Positive 4i, right? All right, cool. All right, focus. All right, here we go. So I need you guys to really focus. This is where if you don't focus, you're going to confuse yourself. So what we're now going to look at is we're going to look at some division problems where there's radicals involved. It's not super hard, but you have to understand something. So I'm going to get to that. So everybody just look up here. This is useful in the future. Do you guys agree that if we were to see the square root of 2 squared, the root and power cancel out, and that leaves us with the value of just 2? Yes, we talked about that last time. So if I were to see the square root of 3 squared, what's happening?
Cancel.
The root and the power are undoing each other, which leaves me with a 3. So understand, watch. If you have a radical, a square root, what undoes a square root? A square, right, everybody? What undoes a square root? A square. Okay, so look at what happens. That would then get rid of my radical. Is there a radical in this answer? Is there a radical in this answer? No. Okay, yes?
Does that mean a cubed root cancels out a cube?
Yep, exactly. So you make a good point. A cube root needs a cube to cancel out. And yeah, those would just undo each other. You make a great point.
Quartile,
yep, it always works that way. Awesome. All right, now listen to what I'm telling you. I am verbally telling you something. You're not talking because then you're going to miss this. No wonder you guys think this is hard because you're not listening to what I'm saying. All right, so it is just not considered simplified, quote, simplified, in a final answer to have a radical that simplifies. Remember, this as an engineer is a decimal, yes or no? Yeah. That's true. But as a math teacher, that's not a pretty answer. Root 8 simplifies. We don't write final answers without simplifying our radicals. Now, would you agree that root 3 is simplified? Because it is, yes?
Yeah.
But here's the fun fact for you. Whoever forever ago decided, a bunch of mathematicians decided, you know what? It's just not pretty to have a radical in the denominator. So let's just fix it. Let's write the same answer as that, the same decimal answer, but write it prettier. And so they do the process that we're about to do. It's called rationalizing the denominator. Have you ever learned to rationalize the denominator before?
No.
So rationalize means make the radical go away from the denominator.
Okay.
Because it's not mathematical. Here's what's annoying. Mathematically, it's totally fine to have a radical in bottom. It's just now not an accepted norm. You would never see it on an ACT. You will never see it in upper division math. So we do have to jump through the hoop. Yes?
Can you multiply the bottom and top by an exponent to get rid of the radicals?
You can't. So here's what we have to be careful of. I'm really glad you asked that because you know what? I did not think of that. This is why we ask questions. Okay, now look at this. I need you to write this in your notes. Okay, don't talk in between. 2 root 2 over root 3. I need to explain to you why this is considered not simplified. This is an okay decimal number. It's just not a pretty math teacher answer. Now why? Because it is not considered pretty to have a radical in the denominator. You all heard me, right? I've said that now a few times. So we can fix it, but we cannot change the value of our answer. This is a decimal value. So watch. If I were to take that decimal value, let's say we took 2 root 2 divided by root 3, and I said, you know what? I can square it. Is that the same decimal value now?
No.
Is 4 the same thing as 4 squared? No. Okay, so you now changed the answer. You can't change the answer. I need the same decimal value, just written differently. Do you guys understand why we cannot square it?
Yes.
Okay, so everybody, how we're going to do that is, think about this with me. Isn't it true that I could choose to take this number and times it by a 1? If I times by 1, is that going to change the value? No. So we're going to choose to times by 1, but we're going to actually be wise about what 1 we pick. Now, what do I mean by that? Would you guys agree that root 3 is root 3 divided by root 3 1? Yes. So it's a tactical 1 that we're multiplying by. It's a tactical 1. Do you understand? But it is 1. Is that a value of 1?
You're using that type of a 1 for a reason.
We're using a better 1, not just 1, but root 3 over 3.
Root 3 over 3.
Yes.
Okay.
All right, so let me show you how to do that. Everybody, let's do it from start to end. Here you go. You would see this. Oh, dang, I can't erase that.
No, that's easy.
Okay, so
Tactical armory.
if you don't mind, I'm going to rewrite this so we can do it together. In your notes, do you have this written? So you're going to say to yourself, okay, so now this is the thought process. You'd say it's not pretty to have a radical on bottom. So I need to have it be the square root of 3 squared. True? Doesn't it need to be squared underneath?
Yeah.
So how many more 3's do I need if I already have 1 3? You only need 1 more 3. Don't you already have 1? So you're going to only put 1 more 3. But now you've changed the value. So you say, well, if I do that to the bottom and I do it to the top, now I'm just timesing by 1. Isn't root 3 over 3 1?
Yeah.
So it's the same mathematical value. But now our answer is just considered math teacher worthy. So now look what we have on top. 2. And then square root of 2 times square root of 3 is square root of 6. Now on bottom, what do we have? Square root of 3 times square... No, it's not 1.
Nothing.
No. It's the square root of 3 squared, isn't it? 3 times 3 is 3 squared, is it not?
Don't remember this.
But it's just 3.
Okay, yeah, but let's just make sure everybody understands. Do you guys see? Root 3 times root 3 is root 3 squared. If you have a 3 times a 3, can you write it as 3 squared? Can you write it as 9? Okay, it doesn't matter. I'm writing it as 3 squared. Can you write it as 9? Yes, it doesn't matter. They're mathematically the same. So now what's our final answer? 2 root 6 over...
3.
Not 3 squared. Doesn't the square root and square cancel out? 3 done. Now look, I'm telling you. Look, type it in. I need you right now to go to your calculator.
I have one. I just need to
Okay.
replace the battery.
Listen, in your calculator. So in your calculator, I need you to tell me the decimal value of that. Ready, go.
Wait, how?
Go 2, hit in your calculator, hit 2, then hit second square root. See, second x squared is a square root.
Hit 6.
And then 6, then make sure you hit all divided by, you might need parentheses on that top thing. I don't know. Depends on how fancy your calculator is. 2 square roots of 6. I'm going to put the top in parentheses so my calculator is not going to calculate it wrong. And then divide by 3. I get the decimal value of 1.63299. You get the picture. Now here's how you could check on the test. Did I mess up? Well, you should have the same decimal value as the original answer. Because remember, what are we doing here? We are not changing the decimal answer. We're changing the final answer's prettiness. It's a makeover. You're still the same person on the inside. All right. So everybody go. Type that into your calculator. Do you also get 1.63299?
You don't have to do the parentheses.
Okay, cool. Yes.
So, I can't remember which day it was. It might have been 1.2.
Uh-huh.
Where we learned how to write a decimal, a fraction exponent into a square root.
Yeah.
Why don't we just do that with the,
Well, let's see if we did that tactic, if that's mathematically helpful. So look, if let's say you did 2 and then 2 to the 1/2 power, right? And then you had the 3 to the 1/2 power, that's not super helpful because right here they're not the same base, right? If they were the same base, could we subtract them? But it's a 2 and a 3. It's different bases, so you can't put them together. So that's actually not helpful, but it's not wrong. It's just then you're like, oh, that's not helpful. All right, let's try it again. Here we go. We need to see more examples of that.
Are you still recording?
Yes. Good question, but make sure you keep on top of it. Like, I'm not annoyed you're reminding me because I literally keep forgetting. But I haven't forgot on this lesson. Okay, look at this. You'd say this is mathematically, each radical is simplified. That is true. Mathematically, are each of those radicals simplified? Yes. Then you'd say this answer is just not math teacher worthy. Let's give it a makeover. The only makeover is timesing by 1. Let's do a fancy makeover. What is it going to be that we need to multiply by? Square root of 2. You got to put a square root on it or you can't put it under the same root, right? You can't just say times 2 because then you can't just float the 2 under the radical. You need a radical.
But I just don't know how we got that there.
So once again, let me show you. This is a great question. Other people don't know either. Everybody, like right now, everybody look. This is going to help kids. This is really going to help the kids that don't get why we're doing that. So right now we have this. We need it to be the square root of 2 squared. True?
Yes.
This is the need. Now, right now we already have 1, 2. So how many more 2's do we need?
1.
Just 1 more 2. Because then, now what are we looking at? This. And then it cancels out. So when you come back to here, you'd say, I already have 1, 2. I need another 2. But you have to put it under a radical, right? You can't just have a 2. Does that help? Are you lying to me? Are you lying or you actually get that? Okay, so if you do that to the bottom, you're also doing it to the top. So what's the top answer? Root 6. On bottom, we have the square root of 2 squared. Why? Because it's 2 times 2. 2 times 2 is 2 squared, my friends. Could you write it as 4? Yes, it's the same thing, right, everyone? You guys are listen, are you listening? Is this the same thing as the square root of 4? Yes. Why am I choosing to write it like this? Because that's just my preference. That's just my preference. Do you like root 4 better? Than do that. But then what's the answer? Root 6 over 2. It doesn't matter. What if you would have had square root of 4? What would you also have as an answer? Same thing, right? You'd have a 2.
Wait, so it's the root on the numerator doesn't matter?
Nope. A root on a numerator is considered fine. It's simplified, good to go. Okay, practice again. Can we do this one right here?
Yes.
Write it down, write it down. Focus. Okay, focus, focus. Here we go. When I see this, the first thing your thought process should be is, okay, I first should simplify any radicals that simplify. Don't start rationalizing right away. That's not a smart tactic. What does this become? 7, right? Square root of 49 is 7. Then right here on the bottom, this is the square root of 5 times 10, which is 5 times 5 times 2. I'm going to write it like this and then say, okay, so this actually simplifies. So we have 7 divided by, when you said 5, 2, I want you to try to say it as 5 square roots of 2. Now, if you circle that answer, decimal, if you're an engineer, cool, you're good. But as a math teacher, it's not pretty because of the radical in the bottom. Top, it wouldn't matter. There's not a radical on top, but if there were, it wouldn't matter. Okay? So then you'd say, I need to get rid of the root. Root 2. I can't do it by anything other than timesing by 1. How many 2's do I already have? So how many more do I need? Just one more. True, everybody? One more 2. So then you're going to multiply by root 2. If you do that to the bottom, you got to do it to the top so that you're timesing by 1.
Why don't you do it by
Yeah, why don't you?
5?
Because is this the radical part? Is there a problem
I
there?
like the 5 there.
The 5's fine.
It doesn't change the five.
And it wouldn't even change the 5. If you times by 5, what's it now? 25? You know what I mean? Isn't 5 better than, you know what I mean? You got to be careful. All right. I mean, you could do 5, I guess, but then your final answer will simplify. So let's just take care of the radical part because that's not the problem. So now what do we have on top? 7? Square roots of 2. You can't put the 7 under the radical. It doesn't have a radical. True?
Yeah.
But over here we have a 5. And what are we timesing the 5 to? Square root of
2 squared.
2 squared or 4.
And then gets out and it's.
Now from here you'd say I think advancedly, so I just be careful. I have 7 root 2 on top, don't I?
Yeah.
But on bottom I have a 5. That is a times sign. 5 times what value? 5 times 2. So then you'd say, okay, my final answer is 7 square roots of 2 all over 10. Now I check. Is this decimal the same as this decimal? Sweet. I did not mess up then. If the decimals are different, you'd say something went wrong. Let's retry this. Let's see where it went wrong. Yes.
I don't have a question about this. I just had a random question.
Okay.
Can you add the square root of 3 plus the square root of 2? Would that be the square root of
We did actually learn that last time. Remember, to add radicals, the radical has to be the same and underneath. And then they're apples.
What if they were multiplying? Then
But multiplying, totally fine. Put them under the same radical. I'm glad you asked that. Okay, ready, go. Do 10 and 12. Ready, go. Do 10 and 12.
Oh my goodness.